Now, what from the north or from the y-axis, the angle the force makes is 90. So this is the direction of the 315 Newton. But class, what angle does the force makes with the x-axis? What angle does it make with the x-axis?
90 degrees.
No, open your eyes. This is the x-axis. Okay, the angle it makes, the force makes with the x-axis is equal to what?
0.
Come again. What angle does the force make with the x-axis? This is the x-axis. What angle does it make with the x-axis? If a vector lies on another, what is the angle between the vector and the other vector? If a vector lies on another vector, what angle does it make with the other vector? Yes, Irene. If one vector lies on another vector, what angle, okay, can be established between the vectors? Inshira, Gloria.
It is a 0.
It's 0. It's 0. This force is lying on the x-axis. Please, is that okay? The force lies on the x-axis. So if you are resolving it to the x-axis, because the angle between the force and then the x-axis is 0, this is 315 cos of the angle, which is 0 degrees. Now, what is the angle between the force and then the y-axis? What's the angle between the force and the y-axis? Patience.
It's 90 degrees.
90 degrees. So 315 sine 90. If you are taking x, the x usually goes with, if you are using the angle the force makes with the x-axis, then it is always cos and sine. If you are using the angle the force makes with the y-axis, then it is sine and cos. Let me explain this to you. You see, in the first one, when the angle is 30, 22, okay, when we're looking at the angle the force makes with the x-axis, we are our component was, this is 60, 22 cos 60, 22 sine 60. I hope you got this right. I hope you got this right.
Yes, please.
Now, when we're looking at the angle it makes with the y-axis, 30, okay, I said we came to the realization that this part, because it falls within the x-axis, though it's 22 sine 30, this part, 22 cos 30, and so our component became 22 sine 30, 22 cos 30, and the value was the same. So if you are using the angle the force makes with the x-axis, it is cos sine. If you are using the angle it makes with the y-axis, it is sine cos. Are you okay with that?
Yes, please.
Good. So here because I'm considering the angle, the force mixed with the x-axis, I have 315 cos 0. Then the angle it makes with the y-axis, 315 sine 90. Okay. And what is cos 0? Oh, sorry. This must be I'm coming. The angle it makes with the y-axis first. So 315 sine 90 and 315 cos 90. Okay, 315 sine 90, 315 cos 90. And sine 90 is 1. So the horizontal component becomes 315 Newton. Then cos 90 is 0. Okay, and so I think Gloria and Trifina also got it right. They also got it right. Kudos to you. So because you are using the angle it makes with the y-axis for 90, 315 sine 90, then 315 cos of 90, giving us 315 as against 0. Let's resolve F3, Trifina and Regina. Here's 210. 210. This is 90. I'm measuring 120. What do I have to add to 90 to take me to 120? So 90 plus what gives me 120?
30.
So I have to measure an acute angle of 30 to usher me into 120. Please do not make the mistake because in bearings, angular measurement is from the north. If you are not careful, you take it, you determine the angle anti-clockwise. You go this way. The moment you go this way, it is wrong because we are taking it to the north. So this is 240. Okay, it means that the corresponding acute angle of this is the 30 degrees we are considering, and that's the angle it makes with the x-axis. Of course, if we consider the angle it also makes with the y-axis, this becomes 60. Okay, so let's resolve the this force into the vertical and then the horizontal. The vertical is this, the horizontal is this. So the horizontal component becomes, since this is the horizontal, of course, cosine will be the appropriate. So 240 cos of 30. Then the vertical becomes 240 sine of 30. Okay, we can also use the angle to the y-axis. If we use this angle, then this side, which is also the x, becomes 240 sine of 60. Then this component also becomes 240 cos of 60. Both must give us the same result. So x and y, the x component is 240 cos 30. Here I'm free to use either this or this. Okay. Then the y component is 240 sine 30. But look at this. The y component falls within the negative y-axis. It falls within, this is negative over here, y is negative, x is positive. Okay, because x is positive, this becomes positive. Because y is negative, we attach a negative to this. Okay, and so we have, what is cos 30? Cos 30 is root 3 on 2. So 120 root 3. And I'm sure 120 root 3 would give us 207.8. So we have 207.8. And then sine 30 is half. So 240 times half would give us minus 120 Newton. And so they also got it right. Okay, please, this same thing can be done straightforward without looking at the corresponding acute angle. I know that 240 measured from the y-axis is 120. So 240, straight away, it can be 240 sine 120, and then 240 cos 120. Trifina and Regina, I'm sure this is the method you used. Right?
Yes, please.
And
Yes, please.
Yes, please.
you didn't want any trouble. But yes, it will also give you the same value. All right. So thank you so much. In fact, you've done so well for getting it right for me. Now, after resolving each force into 8 various components, you come to the next part. Edith, are you following?
Yes, please.
Okay. After resolving each force into component, you sum up all the forces. Summation of Fx. So the F1x plus F2x plus F3x. Irene, are you there?
Mr. GIS, please.
Okay. Now, F1x is equal to 11. So 11 plus F2x. F2x is 315. Then F3x. F3x is 200 and, let me make it approximately 208. Sum everything up for me. 11 plus this plus that.
534.
So 534 Newton. Then you come to summation of Fy. So here we are talking about F1y plus F2y plus F3y. So we have 19.1 plus 0 minus 120. And so this will also sum up to
minus 100.9.
minus 100.9. So approximately 101. Okay. So after summing every force into x and y components, we redraw. Look at what we got for. We got a positive value for summation f of x. So let's draw the axis. X and then y. Because summation f of x is positive, it will be placed along the positive x axis. So it will be here. This is summation f of x, which is equal to 534. Meaning that if this had been negative, okay, it would have been along the negative x axis. Are we okay? Are we okay?
Yes, please.
Good. Then summation f of y is a negative value. So it will also be along the negative y-axis. So summation f of y equal to 101. Please, here we are not going to write negative 101. Why? Why aren't we going to why aren't we representing this as negative 101 but 101? Yes. I want somebody to help us. Why? Because the magnitude is negative 101, but in writing it, we are using the magnitude 101. Inshira, why?
Please, because from where we have drawn it on the number A, on the where I've drawn it, you can already see that it's negative.
So good. Because you see, because by writing it along the y-axis, the negative y-axis, that naturally takes care of the negative. Okay. You didn't write it along the positive, brought it along the negative because of this. So by bringing it down, you have already taken care of the negative. Please, are we okay?
Yes, please.
Good. Now, we have two vectors. Two vectors, one in this direction, another in this direction. You find the resultant, isn't it? Isn't it? So by applying vectors, resolving it into equal vectors. Vectors are equal when they have the same magnitude, direction, and are parallel. So this goes here, and by triangular law of vectors, the resultant will be in this direction. This is the direction of the resultant, theta. So because this is perpendicular to this, we use what do we use to find the resultant? What do we use to find the resultant? Oh, hello. What do we use to determine the resultant here? Irene, Inshia, Gloria, Regina, Anisha, Patience. Yes, what do we use to find the resultant?
Mr. Elia, please, I think I use the Pythagoras theorem.
Exactly. Let's not waste time, okay? But you see, and then do not be afraid to, make mistakes. Mistakes are part of the game, okay? Just express your view and we'll move on. Okay. So we use Pythagoras theorem to find the resultant. So r squared is equal to summation f of x squared plus summation f of y squared. Okay, so 534 squared plus 101 squared, and r is equal to the square root of all that. What's the final answer?
543.5.
543.5 Newton. Okay. Then the next question is about the direction of the resultant. That is the direction of the resultant. Okay. Its direction is along east of south or south of east. It's within this quadrant. Okay. So we first would have to determine this angle. Then, because in bearings, angular measurement is always taken from the north, we add this to 90 to get the direction from the north, okay? So if you are at the north and you want to face the direction of the resultant, it means you have to turn through this angle, okay? So this we know is equal to 90. We will have to calculate for this and add it to 90 so that we can determine the direction of the resultant from the north, because conventionally, angular measurement is always taken from the north. Please, are we okay?
Yes, please.
So, because we have this, and we have the hypotenuse, we can use any of the trig ratios to find theta. So theta, tan of theta, which is equal to the opposites, 101 divided by the adjacent, 534. So please divide it, take the tan inverse, and then give me the value of theta. Gloria, are you there?
Mr.
Please,
Asia,
10.7. 10.7.
Give it to me in the nearest degree. So 11.
11.
Good. Okay. So it means that the bearing of this will be equal to 90 plus 11, which is 101. 101 degrees. And we will take this because, you see, when we were considering the angular measurement, we were always taking it from the north. So in where angular measurement is taken from the north. So this becomes the direction of the resultant. Any question? Anne, why is you ended here? You ended at 11.
I didn't even get it.
Ah, okay. So this is the direction of the resultant. Now, this was a loaded question. Yet you have to find the equilibrium. I said, what is the magnitude and direction of the third force? Please, this must be a fourth force, not a third force. Please, Irene, you have a question?
Mr. Asia, please, it was a mistake, sorry.
Okay. This must be a fourth force, not a third force, because we already have three forces. What must be the magnitude and direction of the third force, the fourth force that will keep the vehicle in equilibrium? And this is about the equilibrium. Equilibrium is a force, okay? It's a force which renders the total forces in equilibrium, or which sets the net force acting on the system, okay, to be zero. So when the equilibrium comes in, the net force acting on the system is equal to 0. So this question is about the equilibrium. Now, the equilibrium has the same magnitude as the resultant, and its direction is always opposite to the direction of the resultant. So if the resultant is going in this direction, the equilibrium will be moving in the opposite direction. It is a force that renders the net force acting on the system to be 0. Okay, so when that fourth force comes in, we have equilibrium state where the net force is equal to 0. So if the resultant has a magnitude of 345.5, the equilibrium would also have the same magnitude. Now look at the direction. The resultant faces this way, then the equilibrium must face in a direction opposite to it. So the equilibrium, which is the fourth force, let's represent the equilibrium by F4. Would go a direction against the resultant. Please, are we fine? Are we okay? Everybody is fine. Are we fine? Trifina, Regina, Janisha, Patience, Edita, Irene, are you okay?
Yes, please.
And you are tired. We'll finish soon. Don't worry. Okay, so we have the magnitude. The magnitude of the equilibrium will be 3, 4, 5, 3, 5, 4, 3.5. But what about the direction? Let's see. If this is not, if this is theta, this will also be theta. Due to what's the reason for which this would also be theta? What's the reason? Adita, what's the reason? If this is theta, this side will also be theta. Why? Due to because of Trifina. Why? If this is theta, this will also be theta. Why?
Please, I think because they are opposite.
So what is the mathematical concept here?
Vertically opposite angle.
Exactly, vertically opposite angle. So once this is 11, this will also be 11. If this is 11, what will be this angle? What will be, if this is 11, what will be this angle? Irene.
Yeah.
Yes. If this is 11, what will be this angle?
Please, which one?
Irene, open your eyes. I said, because of vertically opposite angles, this is 11. And so this will also be 11. What will be this angle? Irene, you are thinking far. Inshira, what will be that angle?
Please, to be 79.
So 90 minus 11, Irene. Okay.
Yes, please.
So 90 minus 11. Meaning that angular measurement is taken from the north. So if I'm here and I want to face the direction of the equilibrium, I have to turn in an anti-clockwise direction through an angle of 79. So the bearing of the equilibrium F4 has a magnitude of 5, 4, 3.5 and a direction of 79 degrees anti-clockwise. Okay, I have to turn an angle of 79 degrees anti-clockwise, or you can express it in bearing form. 79 and north of 79 northeast. North. This is west anti-clockwise. Somebody else can also take it this way. Oh, since in bearings we are always taking from the north in a clockwise direction, then to get the direction of the equilibrium, I would start from the north, turn through this angle. Even though it doesn't make sense or it's so much, but we can also look at it this way because of convention, how things are taken to be done. So if the person is going this way and this is 79, what will be the angle from the north? What will be the angle from the north in a clockwise direction? Yes, Trifina. What will be the angle from the north in a clockwise direction? Trafina. Try.
5M. I'm not sure.
But what? Just give me your opinion. If I want to follow convention, okay, and I want to face the equilibrium from the north, so I have to turn this way, okay. So what will be this whole angle? That's what I'm saying. Inshira,
Please to be the 90 plus 90 plus 90.
no,
Plus.
Inshira, it's waste of time. I understand your view, but you have to see it. Regina, what do you also
Okay.
think? Patience.
Please, 281 degrees.
How did you get that?
Please, the angle from the north, so it will be 90 plus 90 plus 90 plus 11.
You
Or
also
360
going
minus.
exactly
360 minus 79.
exactly. Okay, because this is already 79. So if you are looking for this whole angle, then subtract 79 from 360. Okay. So either 79 degrees anti-clockwise or what you called 260 minus 79, which is
281.
okay, 281 degrees. Okay, as for that, we don't state it. We don't state clockwise because that is the convention. Conventionally, in bearings, angular measurements are taken from the north in a clockwise direction. So if you take it in a clock, we don't indicate. But the moment you are going the other way, then you have to state that anti-clockwise because it doesn't follow the convention. Please, is that okay? Is that okay?
Yes, please.
So I think this is what you answered by going through. I think the verdict is clear to all of you. All right. So I think we've done a lot of calculative things. So I'll draw the curtains on today's meeting here. But please, I forwarded an assignment. Please do it. Take a shot and then send it to me on WhatsApp. I'll mark it instantly for you. Is that okay? And it's a must. It's a must. The deadline is today at 6. So let me get the feedback from all of you. We are not so many.
Yeah.
Hello.
Please, I can't see what's at the fine.
You can't see what is at the far end.
Yes, please.
Can you see now?
Yes, please.
Okay. So do the assignment, send it to me on WhatsApp, and I'll look at it for you. Please, is that clear?
Yes, please.
If you don't bring it, I'll report you to your parents. Monday we'll be starting. I say Monday next week. We'll be starting a new topic. We'll begin with light. Okay, we'll begin with light. So I expect each one of you to be present so we can start on a fresh note. All right. So until Wednesday, the meeting, no, it's Tuesday. Tuesday, same time from 12 to 2. Bye-bye to all of you, okay?
Bye.
I'll be looking
Bye-bye.
forward, to receiving your assignment.